now.
Hi, everyone. This is Damian Carlson with professional VMware.com vBrownBag US. It is Wednesday, December 17th, 2014, and holy crap, where did this year go? So anyhow, tonight we've got Ahmad Yunus. He's going to be hosting. I'm just kind of a guest person to talk about the giveaway. And we have Mr. Nick Anderson at commandline_, that's CMDLN_, and he's going to be talking about CFEngine. So let's handle some quick show notes before we get into the giveaway details. You can always follow us on Twitter at vBrownBag. You can participate in the vBrownBag conversation using the hashtag vBrownBag. You can hear our other podcast properties that we do around the world. You can go to professionalvmware.com/brownbags and register for our Asia Pacific, EMEA, Latin America, and of course US. This one, you probably already registered for this one if you're attending live. So, hey, how's it going? You can download the podcast. We've got the links there at professionalvmware.com. I won't spell those out because that's pretty lame. And again, my name is Damian Carlson. I'm 6-foot dad. Ahmad Yunus is the co-host, and Nick Anderson is our guest talking about CFEngine. So, for those of you who may not know, vBrownBag was pleased to be able to partner with a number of different groups within the community as well as podcast sponsors to do a pretty amazing giveaway. Frankly, I wish that I could have entered because there's some pretty awesome stuff on here, but since I'm part of the podcast group, I'm automatically not allowed to go. I should have entered my children. That'd be pretty great. My 4-year-old wins $700. Hooray! But anyhow, so without further ado, let's go ahead and kind of jump into this. So number one, the winner of the Synology DS413 with 2 terabyte drives, courtesy of John Frappier, that is Damian Carlson. Rock on! How did that happen? That's actually going to be David Cervase. Congratulations, David. You'll be getting an email from us as well as some follow-up details.
Dude, you said it must be present to win, so...
Oh, we default to Damian. Let's see. Number 2 on the list, we have 2 winners of the HP micro server. One is Mr. Joel Sprague, and then the Dan Barr. What's up, Dan? How's it going, dude? 2 winners of the Home Lab Kit, courtesy of ClearPath Solutions Group. Oh, and by the way, the HP microserver was sponsored by HP. Thank you, HP. The Home Lab Kit sponsored by ClearPath is, I'm looking at the list that John sent me, and it's out of a different order from the PowerPoint, so I'm waiting for my 2 brain cells to kick in here. All right, 2 winners. We have Jeremy I apologize, Jeremy, if I mispronounced your name, and Nick Carbone. Congrats, guys. Let's see. We have 8 winners of Micron SSD drives, courtesy of Micron. First up, Mr. Eric Shanks, IT Hollow. What's up, dude? Congrats. Brian Welch, Anthony Center, Mark Handlin, Michael Tabor, Tracy Ratz, Scott McDermott, and James McElhaney. Congrats, everyone, and thank you to Micron. Next up, EMC Education Services. We have the Cloud Architect Series, and the winner of that is Mr. Hersey Cartwright. Congrats, Hersey. Haven't seen you in a while. Hope you're doing well. Next up, we've got the Veeam swag bag, courtesy of Veeam. They're a long-time sponsor, and we appreciate everything they've done for the podcast and for the community. The winner for that is Mr. Jared Shaver. All right. Next up, we have 5 of the Mastering vSphere books written by vBrownBag's own Nick Marshall. Those folks are, actually we've got 5 of the print that would be signed by Nick and then 5 of the ebooks. So for the ebooks, we have Bob Sutter, Jason Cornick, Tom Buckley, Dan Berkowitz, and Chris Latica. And for the signed physical books, we have Brandon Heath, Michael Idindan, Mike Hashimi, Jason Weir, and Guy Fisher. Congrats, everyone, and thank you, Mr. Nick, for doing that. Next up, we've got an Amazon Fire Stick donated by Brian Krausen, and the winner of that is Brian Trainer. And then, let's see, Mr. Cody Bunch, our founding guy, he donated 2 copies of the OpenStack Cloud Computing Cookbook, version 2, I believe. Let's see, where is this on this list? Yeah, there we go. That would be Mr. Ben Bertka and then Robin Naundorf. Thanks, everyone. And then we have a gift card donated by myself and the other guys with the BDB. The winner for that is Paul Maney. Congrats, Paul. It's a pretty great a gift card. And then next up, we have a podcast starter kit that was donated by Ahmad Yunus and the other folks from the Be Recognized group. And that's Mr. Robert Novak. Congrats, Bob. And then finally, I don't see it on the slideshow, but I hope I'm not wrong in saying this. It looks like we have a gift card from the good folks at Virtual Design Master, and that goes to Joshua Pickens. So thank you to all of our sponsors and folks within the community that donated things to the podcast for our annual end of year giveaway. And thank you to everyone who won stuff. I guess congratulations as well. But you know, overall, thanks for making it a great year for 2014. Those of us, including myself, who work on the vBrownBag podcast around the world, as well as the vBrownBag Tech Talks, we're all pretty blown away by what we've jointly done here, and it's a pretty great thing. So thank you very much. I sincerely appreciate each and every one of you who contribute and participate. And without further ado, I'm going to stop talking, and I'm going to turn it over to Mr. Nick and Mr. Ahmad, and let you guys go from here. Thank you again. I'll talk to you guys next year.
Thanks, Damien. So, Nick, you ready?
Oh, man, for a second I thought I was going to be on mute the entire time. I didn't know who to talk to. Please tell me I wasn't muted for the past 2 minutes.
You're going to have to repeat that all over again.
Oh, no, I'll just email everyone.
All right, Nick.
All right, I'm going to stop sharing, Nick, and pass you the GoToMeeting equivalent of the ball.
All right.
Actually, it looks like you already did that, didn't you, Ahmad?
Yeah.
Super awesome. All right, guys. Thank you. And thanks, everyone.
Thanks, Damien. So I guess I'll get started.
Yeah, all yours.
All right. So here to talk about CFEngine. It's the original configuration management system. It's been around since 1993. It's on its 3rd major rewrite of the code. Version 3 was released, I believe, in around 2008. Distributed system and autonomous. It's a little bit different from pretty much everything else that I've ever seen in the world. And I absolutely love it. Let's see here. It was originally designed by Mark Burgess, who is a theoretical physicist. And he was looking for a way to bring some sanity to some of the machines that he had to manage, and got interested in it, and started doing a bunch of research on how to bring some consistency to the chaos. Version 1, like I said, was released in 1993. Don't remember when version 2 was released, but it was used all over the place. In fact, you'll still find CFEngine 2 all over the place. I still meet people all the time who are using ancient versions of CFEngine. I talked to a guy last year who was still running 1.1 somewhere. It just keeps going.
Looks like
So in 2000,
comment version 2 was in 1998.
Oh, that sounds about right. In 2008, Mark had been doing some work. I've been doing a lot of research and thinking about ways to improve CFEngine 2. It was also around that time that other people were looking for better, better ways to do some different configuration management tasks. That was around the time that Puppet came out. Wasn't much longer after CFEngine 3. I think that Chef was first released, and then more recently you've had some other tools like Salt and Ansible, things like that, different ways to do things. So CFEngine 3 is designed on this premise of promise theory, and one of the basic tenets of that is that you can't obligate somebody to do something. It's really hard to distinguish remote command and conquer from an attack from the outside, and it's much easier to look at your surroundings and decide for yourself what the appropriate thing to do is. A lot of times people will use like a GPS as an analogy for that. It'll reroute depending on where you are. If you take a wrong turn, it's okay. It'll recalculate the shortest route to get there. And the idea behind this is that you bring stability by bringing stability at the lowest level, and then you build up on top of it. So I mentioned before that Mark was a physicist. So some of these ideas come from his background in physics. This bottom-up approach is kind of like how atoms, we're not all really solid. We're all made up of a bunch of these tiny atoms, and bringing stability to them gives stability to a larger system. Also around autonomous decision-making, making decisions for yourselves, CFEngine is designed much more in the style of a society. In most societies, at least, you don't have somebody sitting up on a throne telling everybody what to do. You go here, it's time for your lunch break, everything else. In most societies, people have a certain level of control. They make decisions for themselves. If traffic is bad up ahead, okay, maybe I'll take this back road. I see that my GPS is wanting to lead me onto a runway or into the ocean, and I know better than the instructions that that's probably not going to be a good thing for me, so I'll take a different route. You don't just take blind orders from an external entity, which is quite a bit different than most other systems. It's the design philosophy is an agent. So you have an agent that you embed inside of your machine, tiny C program, and small footprint, low memory. Runs almost everywhere. I know that there's an agent running at the bottom of the ocean on some robot. I've talked to a guy a couple years ago who was using CFEngine to manage these laser cutters, because I guess these things tend to catch fire. The way that it works is it has a language, a DSL, simple text files. The agent runs, it reads the text files, and then it interprets that. So I like to compare the policy, these text files, to a employee handbook. Everybody in the company gets the same employee handbook. It doesn't matter if you're the CEO, if you're the janitor, if you're the street sweeper. Everybody gets the same handbook, and you decide based on where you are. If you are in the lunchroom serving lunch, you need to wear a hairnet. You know that rule. So in that context, you behave a certain way. And that's very much how CFEngine works. Everybody has a copy of the policy. They run it for themselves based on what's happening on the machine, what they can detect about themselves. They'll activate certain parts of the policy or won't activate certain parts of the policy. Of course, you can, it's typically centrally managed, right? Most of the time, most machines will get this policy from a central distribution point so that you can get this coordinated behavior. This agent is the dangerous end, CFEngine. It's the part that makes change as it reads through the policy and decides that something is not the way it is supposed to be. It attempts to correct that as the default behavior. And CFEngine is so small and lightweight that by default it runs on a 5-minute interval. So every 5 minutes it's inspecting your system and looking to see if something is out of compliance and going ahead and repairing that. We call all of these intents on the system, all of these desires, promises. And that's because promises are, it's something that people can relate to in real life, right? Somebody can, you can promise to feed your cat, your neighbor's cat. You may or may not actually do that. There's nothing that's certainly binding you to do that. If you don't do it, it's a broken promise, and that's not good, but it is something that unfortunately happens. Sometimes things don't go the right way. So there's not just a simple notion of good or bad. There's this notion of something was the way it was intended to be. That would be a promise kept. Something was not the way it was intended to be, but we were able to fix it. That would be a promise repaired. And then we also have the notion of promise not kept. You know, something was not the way it was supposed to be. We tried to fix it, and we failed. And CFEngine just records all of those things, and then you can use some type of reporting mechanism to collect those back to a central place and analyze those for auditing purposes. There's a scheduling daemon that runs. Some people can, run this from cron or some other system scheduler, but it has its own scheduling daemon that you can use. And that scheduling daemon just simply kicks off the agent when it's time to run. And it also listens for connections from another tool called CFEngine, which you can ask a client to run its policy out of turn. I don't myself use CFEngine a lot because usually by the time I finish typing my CFEngine command, the policy has already run because it runs every 5 minutes. So on average, it's running every 2.5 minutes. Then there's a server daemon. The server daemon is how we distribute the policy files typically. You can arrange other ways to distribute policy files. And actually, the server daemon is the one that listens for the connections from CFEngine if you would like to ask a host to run its policy out of turn. I mentioned a collection of these reports. CFEngine's been around for a long time, and we still have a community that's actively building things on top of CFEngine. There's a couple of other companies that have built products on top of CFEngine, active product building frameworks. Evolved Thinking has an open source library of policies that are data-driven and ready to go. So you can download their policy and simply plug in your data about how you want, in what context you want your system to behave a certain way, and the policy will take care of that for you. There's policy for hardening your systems for things like PCI compliance, other auditing type situations. Evolved Thinking also has a reporting engine. The open source version, the core of CFEngine, doesn't have a centralized reporting engine with it, so people have built their own. Delta Reporting is one of those. There's also another company called Normation that has a framework called NCF, another way to manage, another way to organize and manage your policy for what your machines how they're going to be behaving. And they also have a web UI and management UI that they've built on top of CFEngine to make it easier to use CFEngine and provide reporting. There's another framework that is in active development right now called Dynamic CFEngine 3. And I haven't had a chance to look a whole lot into that one yet. It's relatively new, and there's not a whole lot of write-ups on it yet. So I haven't analyzed that one myself. And then, of course, the company, CFEngine, in around 2008 also, there was a company formed around the open source project, and there's an enterprise version of the software that provides a reporting interface, and you can get support and help for your infrastructure. So I have a quick demo. So please forgive me, I'm in a very bandwidth-constrained hotel, and had to reset up my environment last night.
Hey, Nick, we have a quick question.
I have part of my, yep.
So what's the difference between the enterprise and open source versions?
The biggest differences between the enterprise and open source versions are the centralized reporting. There are a few functions in the enterprise reporting to do with coordination based on the centralized reporting that are obviously not available since there's no centralized reporting. But pretty much anything you can do in enterprise, you can also do in open source. There's just no reporting mechanism built out of the box. So a lot of people will write their policies in such a way that they will log more information. Some people will use log aggregation tools or bolt something else on top. Hope that answers your question. Are there any others right now?
That looks to be it right now. Thank you.
Mm-hmm. I guess the other thing is the support with the enterprise version as well. So my demo here is a simple demo. I mentioned how CFEngine is a distributed system. Every agent takes care of making sure that it's going to do the right thing in its own situation. And we think that this brings a lot more reliability to your infrastructure. So in this demo, I'm going to set up just a really simple web cluster, but it's not an ordered series of events that's going to happen. I'm not going to stand up web servers and then stand up the proxy server to tie them together. They kind of just all come up and configure themselves at the same time. I already have my proxy server up, and the way that I'm doing the coordination here is based on the central reporting from enterprise because I had a quick environment to be able to do that with. But I could also have set this up so that the proxy server was querying the web servers directly or using some other type of coordination mechanism. I've seen people plug CFEngine into some of the newer tools like console and etcd to get inventory and configuration data type information, and then have CFEngine be the part that's taking the action on the system and deciding when things are going to be happening. So what's happening right now is my proxy server has already come up. That's what this page is. And it's simply sitting here waiting to be waiting to have information that the web servers are ready and up. And when it knows that web servers are ready and up, it'll go ahead and reconfigure itself with the servers that are ready into its upstream pool, and then it'll start load balancing across those. Again, this is going to take a little bit longer because I'm in, like I said, a severely bandwidth restricted environment, so it takes a bit for my agents to download their packages. So while we wait for that to happen, we'll go ahead and log in and just take a look at the policy that drives it. This is promises.cf is the file that runs by default when you run the agent, or the file that gets loaded by default. And the agent simply goes through an ordered list of bundles. It's called a bundle sequence. And these bundles are collections of promises. So they're individual intents about the system. And these are things like, this file should exist, this file should have this content, on Red Hat systems, this process should be running, or this other process should not be. And for our demo, the important stuff that happens here is these custom additions. So we do some classification. And again, being a distributed system, it's not a node-centric system. And by that I mean, you typically don't think about things from a node's perspective. You don't attach information to an individual node. You don't take nodes and build individual groups. In CFEngine, decisions are made using what we call classes. And this is classes in the original sense of the term, not the object-oriented programming sense. So these are classes of machines, classifications of machines. And in CFEngine, classes are simply an expression that is true. And so that expression can be made up of pretty much any set of attributes that you want. You can build a class based on. We build a bunch of classes automatically. Things based on things you can detect about the system, the operating system, architecture, network interfaces attached, things like that. And we'll take a look at these custom classes. So I have two custom classes that I've defined here. One for a proxy server and one for a web server. The proxy server will get defined if any of a list of, in this case, if any of these other classes are defined. And I only have one proxy server, and I just use the host name for a simple way. So basically, if there's a class called host001, then I'm going to define this other class called proxy server. And this proxy server class will get reused later on to determine whether or not to perform certain actions. I did go ahead and instrument this right here with this meta information. And this is perfectly valid in Community Edition, but really only useful for enterprise if it augments our user interface. And if we have any time at the end, I'll take you through that quickly. I have another class here for web servers, and this class will be defined if the host has an IP that falls within this range. I'm using the really old style of IP notation here. It also takes CIDR. So there's many different functions to determine what to define classes based on, processes that are there, outcomes of other promises. So for example, if I guess we'll see one in a little bit, I have a config file that should have certain content, and in the event that I have to repair that content, I can define a class which would be used to signal that maybe the process needs to be restarted in order to reload its configuration. Let's see here. One of the things that you might notice here is this comment attribute. You'll see a few more of these as we look through some more of this policy. This is one of the things that I think makes CFEngine really unique, and it's one of my favorite things about CFEngine is that it allows you to encode information about your infrastructure, knowledge about your infrastructure, and why these individual statements are important. If you've ever worked in a legacy environment or been in any type of legacy environment, this kind of thing becomes immediately useful. I've been in legacy environments before. Wikis are out of date the second somebody walks away from them. extremely common to neglect accidentally or purposely because it's annoying, to update a wiki if you've had to make a change on a system. But CFEngine makes it very lightweight to just add information about why something is important, and that's what these comments are for. So for in the future, somebody coming through reading the policy can see this, but these comments actually also follow these promises throughout CFEngine's logging. So if you're inspecting logs or you're looking through the UI, you can see this information about why something is important. So it's not just the fact that this needs to be this way, you can record why, so that in the future, people aren't asking about that. The next bundle that runs after that classification, so as the agent would run, it's going to run through and do some other things that were in the bundle sequence. Then it's going to hit that vBrownBag classification. If the host that's running that policy is a web server, it'll define it. If the proxy server, will define it. And then it's done with that bundle, it'll move on to the next bundle in the bundle sequence. And I have basically a branch off here into this vBrownBag main where I activate the rest of my policies from. Oops. So here's my vBrownBag main. I've just got a little bit of inclusion stuff up here. This just allows me to include additional pieces of policy and make my policy set more modular so that I can more easily share it with other departments, other people, and only include the bits that I want without getting confronted with too much information at one time. CFEngine's bundle that I mentioned earlier, right? This is a bundle. And then each one of these is a promise, just like the classes that we saw earlier. These happen to be a methods type promise, which just activate another bundle. And so what we're doing here is classify systems. This is actually just a duplicate. And then we are going to configure our cluster. So you see an extra bit of information here that I included on this one. This is called a promisee or a stakeholder. Again, part of CFEngine's knowledge management aspects. This allows you to record people who care about whether or not this promise is kept on your infrastructure. People who think that it's important. So you can encode, it's free form here. You can encode whatever you want. You could use people's names, phone numbers, email addresses. One of the most common things that I see people encode here are internal document policy numbers. So if you have a mandate from a security group that something needs to be done, and that's because of section 354 in the security document, you can encode that in a policy. And then when you get an email from the security guy saying, section 354 of the security document has been updated, please adjust your configurations accordingly, you're not just lost, right? I mean, how do you go and look at a document and then find what that document relates to in the rest of your infrastructure? You start grepping for everything. You can simply just search for security document 354 if you had a standard way of encoding that number, and it'll immediately show you all of the policies that are related to that. You can review whether or not you're still in compliance. You can make any adjustments necessary, and then you can move on instead of continuing to worry about that. So I've said here, Jonathan Frappier is who cares about this because who asked me to do the demo. So we're going to go into web cluster next. And in web cluster here again, we're going to just activate some other bundles depending on our context. So if I'm a policy server, I'm going to identify which web servers are ready because I need to prepare information to be distributed out to all of the clients. All of the clients, like I said before, they download their policy and they run with the policy that they have. The distributed system, if the policy hub isn't available, that's okay. They'll continue operating on their cache. If it is available, they're going to go ahead and update it. But this policy right there is just to make sure that the Policy Hub can construct the information to deliver it to everybody else in a way that is easily cacheable by those nodes. Web servers are going to use a web server bundle, configure themselves, and proxy servers are going to use an EPEL bundle and a web proxy bundle. We need the EPL bundle so that we can install Nginx, because that's what we're using for our load balancer. Let's take a look here real quick at this identify web servers. Let me check over here real quick. I know these packages are slow to download. All right. So if I'm a Policy Hub, I'm going to get a list of web server IPs. And this is, for the person who was asking earlier, one of the differences between enterprise and community. Specifically, this function, host with class, is an enterprise function. Since I was using an enterprise environment, I went ahead and used it. There are plenty of other ways to do the same thing without central hub coordination. So it simply queries the database, and it asks for a list of IP addresses of machines that have a class web server ready. And it takes that list and counts it, and it's going to define some classes when it's ready. If we've defined that web server IPs variable, and if we haven't defined that web server IPs variable, then we're going to specifically define a class of web server not ready. I've got some files that I need to manage. When web servers are ready, I'm going to write out this file, and I'm going to populate it with the IPs of all of the files, or the IPs of all of the web servers that are ready. Anytime that list of web servers that are ready changes, this file will be updated. Clients will download it on their schedule, and they'll adjust themselves appropriately. Anytime I have no web servers that are ready, I'm just going to go ahead and remove this file. That'll be an easy way for clients to know that there are no web servers that are ready. Any questions so far?
No, so far no questions.
All right, so let's go take a look at this web. All right, we'll go look at the web server bundle, and then the these bundles that the proxy server activates. So web servers would activate this bundle. Now I've got a web page that I want to render on my web servers. I have a template that I want to render them from. CFEngine has a bunch of different ways of managing files. It has extensive support for very fine-grained editing capabilities. You can edit columns, positions within files, between regular expression matches, regions, before and after sections, all kinds of things for direct line editing. And then there are also a couple of templating systems. There's a legacy templating system, and then with 3.6, we also introduced a Bluestash templating system. So it's a logicless templating system that's much more familiar to people, and that's what we're using here. So we're going to define this web server ready class if this function returns 0. So remember, as I said earlier, this is not an ordered operation. I'm not running an application for loop. I'm not executing commands to make sure my web servers are ready before I move on to my proxy server. These things are just happening in parallel all of the time, kind of like everything else in the world. So for this, I'm going to define this class if service HTTPD status returns 0. If it doesn't return 0, it fails in some way, then I know that my web server is not ready. If my web server is running, I'm going to assume it's ready. I'm going to render my web page with the template that I have, and I'm going to make sure that HTTPD is installed, as well as making sure that HTTPD is running. You'll notice that the order of operations here isn't necessarily in the order that most people would do it. CFEngine makes 3 passes when it runs. So it's based on the idea of convergence. Again, it's by bringing stability to the tiny parts that you'll get stability at the larger parts. So if you imagine going through this and something fails, that's okay, because CFEngine is going to try again in a few microseconds as it goes through another pass. But additionally, it runs on a loop of every 5 minutes, so it's not that long again before it actually does another 3 passes of the policy. And the 3 passes of the policy isn't excessive, because anything that has been identified as something that was as desired, a promise kept, or was something that we were actually able to fix, we skip on subsequent passes. We only really try hard on the ones that don't work. So if I try and edit a file that was perhaps marked immutable, that wouldn't let me edit it, I would try every single time to edit that file, and I would fail every single time, and then I would write it down in my journal that I failed to edit this file, I failed to edit this file, I failed to edit this file. You could report that in your central reporting system. And here, proxy server. So proxy servers also have a configuration file. I also have a web page that I want to render in case no websites are ready. I have a different configuration that gets rendered. So if I have, so I'll go down here. So I define the class upstreams are ready if I had that upstream file, which was that list of IPs that the hub was writing out. If I was able to download that and I have it, then web servers then my upstreams are ready. And if I have upstreams, then I'm going to go ahead and read that file in, get my list of IPs, and then I'll use that when I render my config. Can't see it here. Can see it here. This doesn't look good with color. So this is a mustache template, and basically it's saying if I have the class upstreams ready, render this section, and if I have the class upstreams not ready, render this section instead. And within that section of upstreams ready, for all of my upstream IPs, just drop them into the file like this.
So Nick, we have a question.
Yes.
So the package management, I assume it's a database that can be used OS agnostic, Apache 2 for Debian and Ubuntu, HTTP-D for the others, for example?
Yes, absolutely. Much like most of CFEngine, it is extremely flexible. The package management system is very flexible. So there are a bunch of package methods, and a package method defines, these here are using one of the simplest ways of dealing with the packages. They're defaulting to a generic method, which on a RHEL system would basically translate to a yum install. But you can completely customize what makes up a package method. There are package methods. I've seen people build package methods to deal with tarballs, package methods to do specific kernel upgrades, different specific ways of dealing with repositories. Maybe you want to ignore some repositories when you're performing some operations. That's all completely flexible. And if you wanted to abstract, you were saying HTTPD versus something else. I'll just drop in here real quick. So we'll say Red Hat. On a Red Hat system, my package name might be HTTPD. And on the Ubuntu system, my package name might be patch 2. And this is a class expression right here. And that class expression, when it is true, applies. When it does not evaluate to true, it does not apply. And all of these that we see here are very simple, but I can get more complex, and I can say for Red Hat systems that are in, say, evening, and Solaris or Thursday. So this is a completely nonsensical class expression. But if this was a Red Hat machine and it had a Solaris class and it was evening, the package name would be HTTPD, or if it was Thursday, anytime on Thursday. So it's extremely flexible. You could say, and it's not Thursday as well. So completely flexible. And the bundles give you the ability to take this complexity and bury it at the right level. So you could have lots of complexity right in front of you if that's the appropriate place to have it, or you could bury it down kind of like I've done here, where we're kind of we're peeling away these layers kind of like an onion to get down into the details of what it means. But from a high level, when I'm reading the policy, all we saw at the very beginning was that, I have a web cluster. Well, what does a web cluster mean? Well, I have some proxy servers and web servers. Okay, well, what does that mean? Right? You can peel away these layers to get all the way down to the details that you need. So here I've got an example.
2 more, sorry.
Oh, go ahead. No, it's fine.
So basically, what about a Windows system, and can the config file span OS?
What about, yes, so CFEngine does run on Windows systems. There are not community packages provided for Windows. That's something that we provide to enterprise customers. There is a group of guys who does build Windows packages for the community over at cfengineers.net. They also provide some other platform packages that we don't build for the community, I think as well as Raspberry Pi packages, Android packages. As far as spanning OSs, absolutely. The configuration file, the policy that you write, is typically distributed to all systems. So you write a policy just like you would, this is why I use the employee handbook analogy. Every single system in your fleet would get the same basic policy. That doesn't mean that there wouldn't be maybe appendix policies or some extra information that each one of those systems might source in. But the basic rule set of what's going to be happening would be shared by everybody. So everybody can read the same thing. Everybody reads the same language. It doesn't matter if you're running Debian, Red Hat, AIX, Solaris, HPUX, Windows, Raspberry Pi, Android, some other crazy embedded system. If that answers your question.
Yeah.
Here I've rendered the my config for my Nginx server, and here I'm setting a class. There's some magic that happens down inside of this scoped classes generic, but I'll just tell you right now that it'll define this class right here, config_repaired, if I had to fix that. And if I had to fix it, it'll go ahead and restart Nginx. So while we were talking, that did happen. My packages did finally get downloaded on my extremely slow internet connection, and my web cluster is up. So 33.3 is the IP of my proxy server, and I've got a refresh in there so that it refreshes itself and then it starts hitting the other hosts. So that's why it's bouncing back and forth between host 3 and host 4. And if I go here and I go directly to host 2, And post 3, post 4, or I can hit the pool. And it'll refresh, and each one of those pages refreshes and takes me back to the pool. So that's how that's working. Let's see here. Okay, so same thing as we saw earlier. We want to make sure Nginx is installed and started. Get out of here, and let's see. I guess EPEL here. I guess we haven't looked at that. Also probably pretty similar to the others. I've got some variables that I need to set in order to expand my EPEL config. And then I also render the GPG key here. Alternatively, I could have orchestrated some type of package download. Oh, I guess that is a quick high level on CFEngine. Let's see here. Go ahead and hop over. Are there any other questions right now?
No. Does anybody have any questions?
If not, then I'll pop over into Mission Portal. Of course, we have a couple of minutes left, so I'll just show real quick the type of reporting that you can kind of see in the enterprise version. Let's see here. So this is the Mission Portal interface. You get a dashboard with an overview of alerts about your system that you can configure, like software updates. I can see that I've got some hosts that have some updates available. Here's some hosts. I can see a report, see the specific packages that are installed, what updates are available, when that information was seen. I can browse around my infrastructure depending on different ways I want to organize it. You know, everybody thinks about infrastructure differently. Some people think about it by OS. Some people think about it by geographic region, application tier, things like that, maybe who manages it, groups, anything you want. All of those things can be classes, any attribute of the system, whether or not that attribute is something on the system that you can detect, like a host name, or whether it's some type of information maybe from an external system, like a CMDB. You can run reports on hosts, save those reports, check out your inventory. Of course, my inventory is pretty boring because all of my hosts are most of my hosts are the same. I did go ahead and define this role class, so we can see that I've got web servers and proxy servers. I can get a simple breakdown of how many proxy servers. 20% of my infrastructure are proxy servers, and 60% are web servers. I didn't assign a role class to 1% or 20%, one host. A few different ways of viewing things, and of course you can get access through a report builder to the database. If you know and like SQL, you can write your own. Let's see here. I can just get a report of host names. And window in my way. There it is. Simple report of host names. Also does some monitoring collection, which I think is off right now for my hosts. Yep. So it's not being collected, as well as Design Center, which I also have deactivated. And this is we've been experimenting with ways to manage your policies from a UI in case you didn't want to be down at the command line like I love to be writing policies. So that's my quick overview. As far as resources, if you're interested in learning more about CFEngine, you can check out cfengine.com/learn. There's some videos there, some simple tutorials to show you how to do a few things. We have 20 years worth of documentation over at docs.cfengine.com. We've got CFEngine on irc.freenode.net, and we have an active mailing list. So I'd encourage anybody to come check it out. Don't know of any system that is as flexible or fast. So, questions?
Yeah, so is there integration with Operations Manager?
Operations Manager. We don't have any out-of-the-box integrations with Operations Manager, but it's not hard to integrate CFEngine with just about anything. Most things these days have APIs that you can integrate with. And depending on your needs for how you want your infrastructure to behave, we can design that. You can design that so that the individual agents are talking to these orchestrated systems. You could design that so that a central point like the hub is talking to the orchestrated systems, or these orchestrated systems could, like VMware Orchestrator. I don't know if it talks back out specifically, but you could also talk with Mission Portal in Enterprise. You can talk to our API to harvest information back out, as well as activate different bits of policy on your system from afar. So we've got some videos up on YouTube. I think we've done some demos before of having CFEngine manage, dynamically manage nodes. I think we did one for ESXi or something like that a while back, where, again, from the CFEngine perspective, dealing with something where we can't put the agent natively, right? The CFEngine wants to do everything from the inside out, go from the smallest level, make local decisions. So if you want to act with something like an API, you would designate one or more systems as controllers or peripheral management systems or something like that. And those systems would simply sit there and be talking to the API, asking for the information they need, inspecting if that information is if that state is the desired state. And if it is the desired state, then do nothing. If it isn't, we'll define a class, which use that class to possibly trigger other information or other behaviors, or simply report on it. So we've done some things where I need 100 web servers, and CFEngine will make sure that there's 100. If there's 101, it'll kill them. If there's 99, it'll bring more up. Or you could take that static 100 number, and instead of being a static number, source that through some math, like I need one web server at every 500 requests per second on my load balancer, or whatever it is. Hope that answered your question.
Yeah. We have another one. So is manageability of agents available over the WAN as well as LAN? And if on the WAN, is it encrypted?
Yes. CFEngine 3.6 introduced a TLS to wrap our protocol, so you can do it over the WAN. It is not a certificate authority model, so you don't have a trust chain to deal with. It's a simpler key model. Make it simple. So yes.
So do we have any other questions? I don't see any coming in on, wait, okay, great presentation from Joe.
All right.
All
cool.
right.
So I will post this. I will post this presentation as well as the Vagrant environment to go with it, and I'll send that to you guys later for inclusion in the rest of the notes.
Okay. Appreciate it. And this will definitely be up here in the next few days on Professional VMware's website as well. So people will be able to go back and review.
Okay, great.
Well, thank you so much. Great presentation.
All right, thanks a lot.